Hey guys, these are the notes on solving systems of linear inequalities. Basically, we're just graphing. I will follow these steps. The steps up here, they're okay too, but I like these steps better. So isolate y. I'm gonna go ahead and subtract 3x on both sides on this one. Then divide by -5. When I divide both sides of an inequality by a negative number, I have to flip that symbol. 3 divided by 5, we'll just leave that 3/5. A negative and a negative makes a positive. 15 divided by -5 will give me -3. And as you can see here, y is now isolated, so graphing it's pretty simple. Begin at -3. Right, begin and then move 3/5, so positive 3/5 up 3, right 5. So from the beginning point up 1, 2, 3, right 1, 2, 3, 4, 5. Before I draw my line in, I have to know if it's solid or dashed. It's actually a solid line, and you can check here for the symbols to see that your solid line has the or equal to, your dashed line doesn't. So since this one has or equal to, this is a solid line, right? Dashed or broken would look like that, right? So this one's solid because it has or equal to, and then I'm shading where y is greater than this line. So I'm shading, I like to use arrows for this. I'm shading above the line. Really the arrows I more so use on the systems down here. I'm going to shade everything above this line because it says greater than, and then you'll see how the arrows actually help in the systems. This one right here, begin 0, slopes -2/3, that's down 2, right 3. This line just says greater than, so that means broken line or dashed line. It is greater than, so I'm still shading above. Okay, so that's it for that. Remember, we're shading where all the solutions to these inequalities would lie. Alright, solutions being points. So, for example, like down here, the point -2 would not give me a true statement if I plugged in -2 for x and y. But over here, if it was like +2, if I plugged in +2 for x and y, I'd get a true statement. That's what the solutions will do. We shade where the solutions are, and then the solutions would technically give us a true statement. Now, if it's a system, here's where you'll see where I'll for sure use the arrows to help me graph. I'll use the arrows to show me where to shade before I actually shade. So on this one, let's see, I want to get y by itself. So I'm going to subtract 2x. And then I'm also going to divide by -1 to get y. When I divide both sides by negative, I have to flip the symbol. -2 divided by -1 is +2. 4 divided by -1 will change that to a -4. This second equation, all I have to do is subtract x, and I will have y by itself. Now, since it's a system, I have to graph both of these on the same coordinate plane. So the first one begin at -4, then the slope is 2, so that's up 2, right 1. This line will be dashed because it's just a greater than symbol, not greater than or equal to. Here's where I use the arrows. So if I'm shading where it's greater than, I'm shading above this line, but I'm just going to remind myself to shade above because I actually have to shade where both lines are pointing to, not just one line anymore, 2 lines. So now I'm going to graph this one, and once I see where to shade this, I'll know the region to shade for both lines. So begin at -1, and then the slope is -1, so that's going to be down 1, right 1. And you can keep going down right one if you wanted. It says greater than or equal to. Better put a solid line on this one. And again, that is greater than or equal to, meaning shade above. If it's greater than, shade above. So this line I'll shade above. And then really I'm only shading where both lines, that's the way I like to do these at least. I only shade where both lines get shaded. So like basically this line is pointing above, so it's greater than. This line is also pointing above, so it's greater than. So I could basically call these regions, these 4 separate regions, I could call them, just to guide you, I could call these regions 1, 2, 3, and 4. And really I'm only going to shade this region up here, the one I labeled with 4, because that's the region where both lines would be shaded. So I got y by itself already on this one. You see all I did is divide by 2 to get y by itself. So begin at +2, so up 2, slope is -1/2, that's down 1, right 2. The symbol's greater than, so I need a dashed line. And then greater than means shade above, so I'll be shading above this line. Again, I haven't shaded yet, I'm just kind of reminding myself to shade above with these arrows. And then the second line is begin at 2 also. The slope is positive 2/3, so that's up 2, right 3. This one is greater than or equal to, so solid line, not dashed. But it is greater than again, so I'm going to shade above this line, and then the region I'm shading is here, where both lines would get shaded. These would be solutions for the system. These would be solutions that would satisfy both inequalities. This next one, just x is less than or equal to 4, so all I have to do is go to 4 on the x-axis. It's going to be a vertical line. It is solid because it says or equal to. This vertical line will also give me an opportunity to advise. It says less than. Normally with less than I would shade below. Since it's a vertical line, I can't shade below. So if it is a vertical line where you can't really shade above or below, remember to the right, these numbers are greater than, and to the left, these numbers are less than. So since this one says less than, I need to shade the left side. Again, just using the arrows to remind me, because I'm only going to shade where both lines overlap. This one, y is greater than -2, so I'll go to -2 on the y-axis. It's just greater than, so dash line, not equal to, right? So dash it. And it's greater than this one, so it's shade above this line for greater than. And the only place I'm going to shade is where both lines overlap, where both lines have solutions that overlap. That's over here. This would represent all the solutions that would satisfy both inequalities. This one here, I'm going to again get y by itself, so start by subtracting x. Now divide by 3 to get y by itself, so y is greater than -1/3 x. 3 divided by 3, that's -1. So I can grab this line, -1. So where I begin, and then move, slope is -1/3 m, so that is down 1, 3 to the right. This symbol says greater than, dash line. If it doesn't say equal to, the dash line is basically saying these points are not solutions. The points that are on the line are not solutions, right? If it's a broken line, because it's not equal to. This one over here, x is less than 1. Go to 1 on the x-axis, dash line again because it's not equal to, and whoops, I forgot. This one was greater than. This first line is greater than, meaning shade above. This second line is less than, even so it's a vertical line. Less than is shading to the left, and then I'm only shading the part where the two graphs overlap right here. So that represents the region with all the points that would satisfy both inequalities. And remember the dashed lines mean that the points on the lines won't satisfy the inequality, but everything in that shaded region is good.